Okay, so for our first exercise, we're doing a polynomial long division exercise. And what is a polynomial long division? So it's basically a normal long division between two numbers, as you guys know already exists. And this is a polynomial long division. So it's the long division between two polynomials. In this example here, we have 2x squared plus 7x plus 7 divided by 2x plus 3. This is how it is formatted as the simple form, not the long division form. And this is how you write it in a long division form, okay? So it's basically the division between the two polynomials. This is how you structure the answer. So as you can see, this is the dividend, this is the divisor, and there is also a remainder, okay? So you put the divisor outside of the division, as you can see, divisor here, and the dividend inside the division, okay? So then there's also a remainder and a quotient, which is this right here, okay? So yeah, this is basically how it is structured. As you can see right here, we have an example, and we have the standard form and the missing powers. Okay, so when you have a number in standard form, it's gonna look like this. And if they don't have a power, so as you can see, x cubed plus 4x squared, so 3x cubed plus 4x squared plus 10, they're gonna be a normal polynomial. And here we added the 0x because it's missing a polynomial, a power, okay? So the missing is a 0. And this is what I said before, but in practice, so kind of showing. So this right here is the divisor, this is the dividend, this is the quotient, which is your answer, and this is the remainder. Now, how do you get to the answer? We're gonna show you right now.
So we're doing this problem right here of long division. So we're dividing the polynomial 2x cubed plus 7x squared minus 4x plus 7 by x squared plus 2x minus 1. Okay, so the first step that we have to do is that we have to put the first number. So what do we have to do to get to from x squared to 2x cubed? So x squared times a number is 2x cubed. This number, as I wrote here, is 2x. So we do x squared times 2x is going to be 2x squared. But we also have to do this and times negative. So times negative 1. So times a negative, okay? So after we do this, this will be 2x cubed negative. And then we have to do this for all the numbers. So this would be 4x squared and a negative. And also for this one, which would be plus 2x, which if you do the calculations is going to be 0. This is going to be positive 3. This is going to be negative 2x. And this is going to be 7 because we just bring it down. Okay, so for the next number, since it is a squared, it's not a 3, so this is my mistake, I'm sorry. We don't have to include an x, right? Because it's already squared here. I have to get to this number. So to get here as a negative, we need a 3, of course. So it's, sorry, x squared times 3 is negative 3x squared. Okay? And then we have to do for all of them, as always, 6x, and here it would be positive, because this becomes a negative, and negative times a negative is a positive. So this would be positive 3. Now if we do the calculations, again, So if we do the calculations, this right here would equal 0, this would be negative 8x, and this would be 10. Okay, and this is the remainder, because we can't do anything less, right? It's already at the minimum here. So this is the answer. Okay, I'll be right back to showing you how you structure the answer, the final answer. Okay, so now we have our answer here in this formula, which is the big D, which is, we're just doing the equal here, right? Because we don't need the dividend and these others, this number right here, which is the dividend. We don't need it here because it's in this side, okay? So this is the quotient, okay? So we structure in a way where it's the quotient, the remainder here, the remainder up here, and the divisor below. And this is our final answer, okay? So this, we got it from the long division, and this is the formula, okay? So I'm gonna repeat: the quotient, the remainder, and the divisor below. This is our final answer. This is the first example of a long division, and let's go to second example. Okay, for example number 2, we have 3x cubed plus 4x plus 11 and x squared minus 3x plus 2. So for this example, it's a little bit differently. I'm even gonna write it here for you, and we're already gonna stop it here. Why? Because for this example, we're gonna need to put in 0x squared, because it's not showing here, which means it's 0. Okay, it still has an x squared, but this time it's a 0. Okay, so here it's normally do this, and we're all set. Okay, so now we can start the problem. So first one, we already know it's going to be 3x. Why? Because x squared, 3x, it's going to be 3x squared, and the negative that we lost right there. Okay, so now the other one is going to be positive 9x squared and 6x, which is going to be negative 6x. Okay, 0, positive 9x squared, and a negative 2x plus 11. Okay, now for the second one, it's squared, it's already squared, so we just need a 9, right? We just need a 9, it would be 9x squared negative. Correct? Yes, it is. So now that we have this one, we do the same process that we always do. So 9 times 3 is going to be 27. It's going to be positive 27. Okay, positive 27x. And then we've got 18, which is negative 18. Okay, so it's 0. Here we have 25x and a negative 7. So this will be our answer. It will be 3x plus 9, 25x minus 7, and we will get back to the final answer like last time and just explain the final result. Okay, so now for the final answer, we have, like last time, the quotient here, we have the remainder up there, and the divisor on the bottom. So quotient, remainder, and divisor make up the final answer that we just got here. Okay, so this is long division. Let's go to the next topic, which is going to be synthetic division.
So, good morning. My name is João Pedro, and in today's video I'm going to do a simple tutorial about synthetic division, which the name kind of scare a bit, but when you start doing it, you'll see that's pretty simple and it's very easy to do, right? It's not a big deal. So, I think first of all, it's very important for us to know what synthetic division is in order to start doing it, right? So basically, it's pretty simple, right? It's just a method of polynomial division in special cases of dividing by a linear factor, which can be not always for dividing out factors, but finding zeros or roots of polynomials. So it's not only about dividing polynomials, about polynomial division, but it's about also finding the root, right? Finding the root or the zeros of the polynomials. So yes, it's pretty simple. Now let's go to the examples. So for today, I separated two examples and two synthetic divisions that I will solve, and I will go through it with you guys. So that's simple. For my first equation, which I chose x cubed and minus 2x squared minus 5x plus 6 divided by x minus 3. Well, so what do we do now? First of all, we need to put numbers here. So for this template, I got so a template with five coefficients, but in this example I only have 4. But it's the same case, right? It doesn't matter a lot. So for my first case, it's simple. We'll get what number is here. Here is a 1 that we can see, right? So we will pass the coefficients for here. So that's going to be, wait, we just put here 1, right, from the x, then 2x squared we'll put 2 here, then from the 5x we'll get the 5, right, and from the 6 you just get a 6. Simple. So you guys are probably wondering why there is a space here in blank. Yeah, what should we do with this place? We should put these 3, because if you solve, wait, because if you solve this for x, the result here will be 3. Pretty simple. So here is just a 3 in my case. In other words, we could make it simple. You just inverse the number that's here. So if it's a negative 3 here, you just put a positive 3 here. That's what I'm going to do. Okay, having this done, now we actually start doing the full count. So what we'll first do? This one we'll just pass here, right? Because it's pretty simple. Then we'll add this. We'll multiply this 3 with this one, which the answer will be obviously 3, right? Oh, sorry, here it's a negative. Wait, yeah, here it's a negative 2. So once I pass this, once I multiply this 3 with this one, which the answer will be 3, you will put the answer here. Okay, so 3 here. Now we will do negative 2 and negative 2 plus 3, which the answer will be 1, right? Here. So now we will do this 3 times this one again, which in the same case, yeah, it will be 3. And we will do it again. And just a second. Yeah, the 5 is negative 2, so I missed here too. The 5 is negative. And for now, we'll have a different result here, because this was negative 2, which was 1, so this is negative 5, which will lead us to negative 2. Negative 2. Right? For our next step, we'll multiply this 3 for this 2 again, for this negative 2, which will be negative 6, right? Negative 6. Which can show us that here 6 minus 6, 6 minus plus negative 6, it's equal to 0. So this is factorable. Yes, this is factorable, which means that it works here. So that's basically it. And yeah, now we can just see it that it's factorable. And how to get this full result here, right? It's a very simple way. So it's pretty simple. So for the x here, the coefficient of x squared, it's 1. Wait, it's 1. Wait just a second. 1 Control C. X squared, right? Plus another this 1x, right? 1x minus 2 from here. So x cubed minus 2x squared plus and minus 5x plus 6 divided by x minus 3, it will be 1x squared plus 1x minus 2. So that's our full answer. So for our next example, it's also pretty simple. First of all, you guys know what I need to do. Move the coefficients to this. So here we have 3, right? So let's use just those 3. 3x squared, we just move the coefficient, which is 3 here, right? Simple. Here. Now for a second, we use 7x, only 7, right? So let's put 7 here. 7. And for our next is negative 20. So negative 20 here. So now you guys know that we need to put something over here, right? Something here in this place here. And what exactly we need to put here? So as you know, it's here. The answer is here. We only solve this for x, which will be negative 5. It's pretty simple. X plus 5. Yeah, right. The equals 0, and then we only pass the 5 to the other side, which will be x equals negative 5. Pretty simple, huh? So yeah, that's not a problem for us. As I already told you guys, it's only we invert the signs here. In this case, it was negative 3, so positive here. In this case, it's positive 5, which will go negative 5 here, right? And yeah, once we have this, it's almost pretty done. I think the difficult part's already done. So yeah, that's pretty easy. We will just move the 3 here, and we'll do negative 5 times 3, which is negative 15. Negative 15. Then 5 plus negative 15, which in this case it will be negative 8, and 5 and negative 5 times negative 8, which will be positive, right? Because negative in the multiplication it's plus, so positive 40 here, right? And in this case here it will be 20, right? Not 0. In this case it will not be 0. So that's not factorable, okay? So that's not factorable by the x plus 5. Now the last part of our tutorial here, and for this here, I'll also solve a long division for the first one. So yeah, for our next part here, we'll know the result, right? Which it's pretty simple. We'll put this 3 here, which is 3x, right? Minus 8, right? And this 20 here, that we'll just put positive 20, but because it's not factorable, right? It's a bit more complicated because, well, it's not factorable, right? So you cannot like this, like it was in this one, right? Because we just ignored the 0. So you put, wait, I need to insert equation here, and it will be plus 20 divided by the number that's here, which is x plus 5, since it's not factorable. So x plus 5, sorry. So yeah, that would be our result. So 3x squared plus 7x minus 20 divided by x plus 5, it's result to 3x minus 8 plus 20 over 5 plus x plus 5, right? So both here are the answers. Pretty easy, huh? Yeah, I expect it to be more hard too, but now let's go to check the results. Let's check some of those results if it's by long division. So now that we've did the second example, how can we prove this, right? Because now that we know how to do it, we need to prove it, right? And there are many ways we can prove this. And the most efficient and easier way is by the long division, which is a pretty interesting and another step which Victor explained had a whole tutorial only for long division. But here I will prove the synthetic division by using long division, which is also pretty simple. I recorded this once, so that's why I have here everything ready, right? And but I will go through it with you guys. So here we will start putting the numbers here, putting here, just like here, and the x plus 5 will go here, right? And that's here it's important because we will work with the negative 20 later, right? So we are working mainly with the 3x squared here, and 7x, in which we will use this here to go through here, right? So here will so the 7 will become a negative 15x because of the 3x minus 8 here that we have here, and the positive 3x squared will become a negative 3x squared, right? And here it will lead us to this right here, right? Wait, this right here. And well, in here we just cancel both here, right? We just cancel because it's 8 and positive 8x, which will lead us to negative 20 plus 40. Well, that's here. That is the key for everything here. Negative 20 plus 40. If we do the count here, the result here will be 20. 20. Now that we got this result here, what can I do? Well, the long division process is basically done. It's a pretty easy process here, which we go through. Working with the axis here, main of the axis, and letting the number of no x behind, and we work with them only on the last step. Only the last step. Now here we got the 20, and look how interesting. Our result here was also 20, right? So here we just proved by long division that that it works, right? That both of them are correct, right? So yeah, it's pretty easy, pretty simple, very easy. And yes, thank you.
Okay, so now synthetic substitution, we have, for example, an f of a and an x minus a. This is the formula. And if you have the f of a, you can switch it to the number that is the a in the other equation as well. So x minus a and f of a, the a is going to be the same. And once you do the synthetic substitution, your remainder will be the same as if you switch the a on the whole equation. So if it's f of x and you have x minus a, that x on the f of x would, if you switch that x on the f of x and put it on the equation, you could check the answer, check if the remainder was right. So it would be the same answer as the remainder. Okay, so that's the thing. X minus a, once you make the division, it would be the same as f of a equals the remainder. Okay, so this is the last part of our project, and it's a synthetic substitution. So, how do you do the synthetic substitution? Let's start with this example here, where we have 5x squared plus 3x, 5x cubed plus 3x squared minus 2x plus 4. And we have to substitute f of 3 for this equation, okay? So, let's start by putting our number 3 in here, okay? So, number 3. And then we have to substitute it for these numbers. So we're gonna have to put 5, 3, all up here, 3, negative 2, and the 4, okay? So we can actually make more space here with this one. And what we're gonna do for the first part is we're gonna lower the 5. We're gonna do 3 times 5, which is 15. We're gonna do 3 times 15. No, not 3 times 15, sorry. We're gonna do 3 plus 15, so we're gonna add those, which is 18. And then we're gonna do 18 times 3, which is going to be 54. So, sorry, not here, we add here, put it up, 54. 54 minus 2 is going to be 52. And 52 times 3 is 156, yeah, which is going to be 160. Okay, so that is the remainder. Okay, so how does this right here look on this equation, the equation that we just made? So we can add this here. So we could actually add that here. Sorry, yeah, we could just add it here. So we could do f of 3 equals 160, right? And how do we check this? Is there another way that we could check this? Yes, there is. So we could actually copy this. Now it's the part where we can copy this down here, sorry. Maybe. Okay, try to lower this. There. Okay, it's fine. So, how can we check this in another way? So we could just substitute the x's, so all the x's here. Actually, I'm just gonna change it so it's easier. I don't know even if it's gonna change, but yeah, it's not. Okay, so I'm just, yeah, it's not gonna change. So what we can do is substitute all the x's here for the 3, okay, to check. How's that gonna look like? I will show you right now. So it's gonna look like this, okay? So this is going to be times 3 times 2 times 3. This is what it's gonna look like, okay? So then we have to do the calculations. So let's do the calculations. 3 squared is 9. 9 times 5 is 45. 45. 3 squared is it's not 9. Okay, sorry, I made a mistake. Sorry. 3 to the power of 3 is 27, because 3 times 3 is 9, and 9 times 3 is 27. So yeah, 27. 27 times 5 is 135. Then we have 9, which is 3 times 3, 3 to the power of 2, times 3, which is 27. And then we have 2 times 3, which is 6. And we have 4. So once we add this all, it's going to be 135 times plus 27, which is 162. And then we have minus 6, which is 156. And then we can do that plus 4, which is 160. Okay, so by substituting it, we actually still find out that this is 160. Okay, so we can do it both ways. Okay, so yeah, by substituting the x, we can also find out that this is 160, right, as we found it right here. Okay, so we're gonna do our second example now, but hopefully you got it by now that this is how to do the synthetic substitution, the polynomial synthetic substitution. Okay, going into our second example, you guys already have an idea of how to do this. So let me just put the -4 right here, put the 3 right here as the first number, -2 as the second number, and then a +4 as the no, sorry, that is what it is written, but this is what I have to explain to you guys that we actually did in the first polynomial example, which was the long division. We actually had this problem, and we have it during the polynomials, which is that when we have all the powers here, there is actually a power of 3 and a power of 1, so it's not only these two. So we put down 3, and then we have to put a 0 because it's x to the power of 3, and then we have to put now the -2 as well, and the 0 once again because it's the x, and then the 4. Okay, so this is actually how you do it. So lower the 3, -4 times 3 is going to be -12, and then yeah, we got -12 here, and then -12 times -4 is going to be +48. +48 minus 2 is going to be 46. Then now it's harder because yeah, 46 times 4 is going to be -184. So -184, and -184 times -4 is going to be +736, and then once we add these, it's going to be +740 is the answer. Let me just, that was very ugly, I'm sorry. Yeah, there we go, 140. Okay, so let's check the answers. It is 3, lower the 3, 4 times 3 is -12, lower the -12, -12 times -4 is a +48, -2, 46, 46 minus 184, negative times a negative. It is correct by my calculations. Okay, so now let's check this answer for real. Okay, let's actually check it by doing this way right here that we did it before. Okay, so I have taught you guys on how to do this, so we're gonna do it basically. First I'm just gonna record our answer, which is 740, and then we can attempt on checking this answer. Alright, so I can easily copy this here, and let's get on with it. Okay, so as I taught you guys last time, we have to change all the x's to a -4. Okay, so change all the x's to a -4. There we go. So this is we're gonna have to use a calculator here because this is not gonna be an easy calculation. So we have -4. We have square root of 4, so not square root of 4, we have to the power of 4, so let's go 4 times 4 times 4. So the first one should be 256. Is it a positive or a negative? Let's see. First, -4 times -4 is a positive, then it's a negative, it's a positive. Okay, so positive 256. And then we have that times 3, which is 768. Okay, I'll just do it here so you guys understand it better. Okay, but yeah, 768 here, and then 2 times negative, it's going to be a positive 8. Okay, no, positive 8, sorry, positive 16. So positive 16 times 2 is going to be 32. Positive 32. Actually, negative 32. Why negative 32? Let's see here. Because when we actually do this, it's going to be negative 4 times negative 4, which is positive 16. So positive 16, and then we actually have a negative what's it called? Negative 2 here. So this is going to be 14. Okay, because negative plus, it's going to be a positive 14. No, it's times. Sorry. Once again, I'm sorry for this. This is 16. It keeps deleting the x. There you go. See, keeps deleting the x, so I forget it's multiplication, but it's not. It is multiplication. So you have to do that times positive 16. Okay, so that times 16 is going to be negative 32. Correct? Yes, it is. Plus 4. Okay, so now that we did the calculations, let's find the answer. We have 756 and 68 minus 32 plus 4, which is 740, which is correct. So that is how you find the answer of a synthetic substitution exercise for polynomials. Okay, that is how you check it as well. So let's just recap. First, you get the negative 4, put it in the little box. You get the numbers. Don't forget to add the zeros if you're missing powers. You do the division, the multiplication here. So you lower the 3, 4, yeah, you multiply, do the normal process, and get an answer. After, how can you check if this answer is correct? I like going over it once, and then if it's correct, I like putting this just to absolutely check that I'm correct. You can get the negative 4, put it into the x of all of the polynomial, and then you're gonna have to times with this. This is a times, okay, not an x. This is the times. So you do 3 times the negative 4 to the power of 4, which is going to be 768. Then you can do the negative 2 times the negative 4 to the square root to the power of 2, and then you get negative 32, and then you do that plus 4, and you get 740, so you know it is correct. Okay, hope you enjoyed the tutorial.